Good afternoon, everybody. Today we will discuss the structure, reactions, and synthesis of the indole. Indole is a bicyclic structure and it's consisting of a 6-membered benzene ring fused to a 5-membered pyrrole ring. And since it undergoes the resonance structures and it shows the aromaticity, the indole is not a basic in character. And it is very much similar to the pyrrole in basic character. The lone pair of the electron which is present in the nitrogen is not at all available for the protonation. So that's why the indole is not a basic compound. And now we are moving into the important synthesis of the indole. The first method is the Fischer synthesis, which is the oldest method in which phenyl hydrazine is react with ketone or aldehyde and we will get the derivative of the indole. Next method is the Madelung synthesis in which the N-phenyl amides react with sodium NaNH2 or RONA in the presence of heating. We will get the derivative of the indole. And we have another method for the synthesis of the indole is the Bissler-indole synthesis. And the last method is the Ricert-indole synthesis. Now we are moving into the Fischer-indole synthesis. The Fischer-indole synthesis is an oldest method and most reliable method for the synthesizing the substituted indole. And it was discovered by the Emil Fischer in 1883. And in which the reaction between a phenyl hydrazine and ketone occurs in the presence of acid medium and we will get the derivative of the indole. Now we are moving into the mechanism. Here we can see that we are treating the phenyl hydrazine with an acid and the acid pick out the lone pair of electron in the nitrogen and the nitrogen become positively charged, and after that it will liberate the H plus ion and undergo the rearrangement, and finally we will get the derivative of the indole. Okay. Now we are moving into the another method, that is Madelung indole synthesis, in which we are using the phenyl amide, N-phenyl amide, and here we are using the strong base and in the presence of heating we will get the derivative of the indole. This is the mechanism for the synthesis of the indole. And here we can see that the intramolecular cyclization of the N-phenyl amide occurs, and finally we will get the derivative of the indole. Now we are moving into the third method, that is the Bissler-indole synthesis. Here we are using the aniline and 2-aryl in 2 cyclization of the alpha aryl amino ketone in the excess of the aniline occurs. And here also we will get the derivative of the phenyl derivative or derivative of the indole will occur. Next, last method is the Ricert-indole synthesis. Here an orthonitrotoluene is react with an the ester, that means the derivative of the oxalic acid. Here it is used the ester of the oxalic acid in the presence of NaOET and we will get the final product as the indole. These are the different methods for the preparation of the indole. Next we are this is the mechanism for the Ricert, the above said the reaction. And we are moving into the reactions of the indole. Indole undergo the electrophilic substitution mainly at the third position, and this reaction is known as the Mannich reaction. And here we can see that the ketone react with the primary amine, and the substitution, finally the substitution of the electrophile at the third position occurs. Next reaction means the substitution at C2 position. So if you are using the strong base like butyl lithium, it will attack the most acidic proton, and after that we are adding EX in presence of water. So the electrophile is added in the second position, C2. The final reaction is the oxidation of the indole. Oxidation occurs. We know that the indole is an electron rich in nature, and that's why it undergo the oxidation very easily. And the simple oxidant such as N-bromosuccinimide selectively oxidizes indole and to form oxynodoles. These are the reactions of indole. Thank you.